Today we are going to discuss about synchronous counters. In mainly the main difference between synchronous counter and asynchronous counter is in asynchronous counter first flip flop only triggered or clocked by an external clock signal or count pulses, and all other flip flops are triggered by the output of the previous or output of the other flip flops. But in the case of a synchronous counter, all the flip flops are using the same clock signal. The output would change synchronously. That is, if there are two flip flops are there, then the two flip flops are triggered synchronously because the same clock pulse is applied to the both flip flops. And the next is to how to design a synchronous counter. There are mainly four procedures or five procedures are there. The first step is obtain the state diagram, and second step is obtain the excitation table using the state transition table for any particular flip flop. That is, if we want to design a JK flip flop, we need to select the JK flip flop excitation table. Then determine the number of flip flops used. Then for third step is obtain and simplify the function of each flip flop input using K-map. If we want to design a JK flip flop, we want to find out the minimal expression for J and K input of each and every flip flop. And last step is, from this minimal expression we need to draw the logical diagram or the circuit. Here is the example of a design a mode for synchronous counter. So design a mode for synchronous up counter using JK flip flop. So here the flip flop is specified here. Which flip flop is required? Here we need to design a synchronous counter using JK flip flop. So it's a synchronous up counter. Up counter means it will count upward. That is, if starts from 0 0, then it will 0 1 2 3 etc. So what is mode 4 counter? Mode 4 counter means it has 4 states. So here first step is to obtain the state transition diagram. So for that, we here how many states are there? Mode 4 means 4 states are there. So we draw that diagram. It is an upward counter, so it starts from 0, then 1 2 3. There are 4 states are there. So upward counter, so it's move from 0 to 1, then 1 to 2, then 2 to 3, and 3 to again it comes to 0. So corresponding binary representation is here. 0 is represented as 0 0, 1 is represented 0 1, then 1 0 1 1, 3 is represented 3 uh, 1 1. So how many bits are required to represent a mode 4? Mode 4 means it has 4 states. There is an equation for the n is equal to 2 raised to n. Here n is the number of states. Here number of state is 4, and small n is number of flip flops required. So 2 raised to, here how many n value? What is the n value? N will be 2. So it requires how many bits? 2 raised to 2, that is 4. So how many number of flip flops are required? 2. So here 2 means 2 bits are required. Here 4 states are there. 4 states represented using 2 bits. So next obtain the next step is to obtain the excitation table. Here we are using JK flip-flop. So JK flip-flop excitation table is here. Excitation table means we are given the present and next input, next output, present and next output. Then from that we are find out the j and k input values. So here qn represents the present state and qn plus 1 represents the next stage. So if we are already studied the excitation table, so we are just draw the excitation table of JK flip-flop. Then from that excitation table, we are using two JK flip-flops are used here. So here represents present state, this present state and next state and input JK. So present state containing there are two flip-flops are there. A represents first flip-flop and B represents the second flip-flop. So here the state for there are two inputs are there. So it is 0 0 0 1. Four states are there, 1 0 and 1 1. This is the present state. If the present state is 0 0, what will be the next state? In the diagram we know that first state is 0, then next state will be 1. So the next state will be the flip-flop state will be 0 1. Then present state of the flip-flop is 0 1. Then what will be the next state? We know that next state will be 2, that is 1 0, that is 1 0. If the present state is 1 0, that is 2, then next state will be upward counter, so next state will be 3, that is 1 1. Now the present state is 1 1. If the present state is 1 1, the next state will be 0 0. Next state will be 0 0, that is drawn here. If the first state is present state is 0 0, the next state will be 0 1. If the present state is 0 1, next state will be 1 0, that is 2. If the present state is 2 1 0, the next state will be 1 1, and the present state is 1 1, the next state will be 0 0. This sequence will be continued. Then from this we need to find out the j and k input. So first we consider the b value. B value is 0 0. Here input jk, there are two flip-flops are there. So first flip-flop is j and ka. The next flip-flop is jb and kb. So first we will find out the jb and kb. For that we have taken the value from the b values of the present state and next state. If the present output value of b is 0 and next output value of b is 0, what will be the corresponding j and k value? Look at here excitation table. Here present value is 0 and next value output value is 0, then jk value will be 0x. So here put 0x. Then next present value of b is 0 and next value output value is 1. So 0 1, then 1x will be the jk input. So take the 1x. Then next is present value is 1 and next value is 1, then 1 1. What will be the output? Output will be the jk input will be x0, that is x0 here. Then next present value is 1 and next output value is 0, then present value is 1 and next output value is 0, then the corresponding jk input is x1. So x1, x indicate don't care. So this is the excitation, jk input value. Then next we are considering the a input, the present state of a and next state of a. First case is 0 1. 0 1 is corresponding jk input is 1x, there is 1x here. Then present output is 1 and next output is 0 1 0 1 0, that is x1. Here it is x1. Then 0 1 0 1, again here it is 1x 1x, and 1 0 1 0, it is x1. So this is the ja and ka value. From this value we are finding out the simplifying the equation, or find out the j and jb, kb, ja and ka values using Carnot's map. So here third step is obtain the simplified function using k map. Here there are two inputs are there, a and b. Then it containing Carnot's map containing 4 cells, 0 1 0 1x. And here for jb, first consider the jb. What are the values? Is 0 1 xx. Here 0 1, put 0 1 xx. So group this cell 1x. Then there is, here it is eliminated, here only b is. Here the first this is the k map. Here we are plotting the put the value based on the present state. Present state ba is first state is 0 0. So 0 0 we are putting 0. Then 0 1 we are putting 1. 1 0 it will be x, and 1 1 it is x. So here we are group first two first group this cell. Then we will get, what will we get? 1x. Here we will get a. And for kb, what will be the kb? Kb will be xx01. So put xx01. So here also we group this cell. Then we will get a. Kb is equal to a. For ja, what will be the input? Ja. For ja 1x 1x. So here put 1x 1x. We can group entire 4 cells, so it will be result 1. So again next it is x1 for ka, x1 x1. For x1 we can group entire 4 groups, 4 cells, so it will be k is equal to 1. So based on this equation, ja ka values, j and k input values, we are draw the logical diagram. So first draw the flip flop. There are 2 flip flops are there. Then j a k a q a, and here it is jb qb. sorry, JB, KB, QB. Then here JA and KA values are 1. So JA and KA values are 1. So it is connected to 1. First we put, it is a synchronous counter. So we put a clock pulse to both, single clock pulse is given to the both flip-flops. So first flip-flops, both flip-flop containing clock pulse, single clock pulse, and first J and K A values are 1. Then JB and KB. What is the value of JB and KB? Its value is A. A means output of the QA. So we are connecting output of here to JB and KB. Then it will be taken. So we will take a QA and here it is QB. That is here. Clock pulse. Common clock pulse is applied to both flip-flop, and first J and K is connected to the 1 and QA output is connected to JB and KB, and QB is the B. This is the A and B are the outputs. So here B is MSB, B is the MSB, A is the LSB. So here we consider 0 0 0 1 1 0 and 1 1 are the output. So this is the circuit diagram. Thank you.